Hello, fantastic followers and Kane. Let's have a look at exercise 3D. So what we're doing today is we're looking at graphing quadratic functions. We'll start off with a basic quadratic equation. So we'll have, great, love that color. Y is equal to x squared. Now, we know it's a quadratic because it's got to the power of squared here. Now, we have a name for it. It's called a parabola. And it looks like this. So y is equal to x squared. So when x is equal to 0, y will equal to 0. When x is equal to 1, 1 squared is 1. So y will equal 1. When x is equal to 2, y will equal 2 squared. So y will equal 4. So it's going to look like this on this side. And if we look at the left-hand side of the y-axis, when when x is equal to -1, -1 squared is 1. When x is equal to -2, well, -2 squared is 4. So we get a similar sort of shape here on the left-hand side. So we call this a parabola. Now it kind of looks like a smiley face. If you were to have y is equal to -x squared, you'd be flipped over the x-axis. So you'd have it would look something like this. Obviously my drawing's not super great. Definitely not. But you can see a better one in your textbook. Okay, so a few things we need to know. We need to know a few more terms. So we've got the range. Now, the range of a function or an equation is all the possible, all the y values. So if we look at the range of y is equal to x squared here, all the possible y values, well, 0, it's 1 as well, it's 4, it's all of these values here that y takes. So it takes any number that's greater than 0 and 0 itself. But we can see that, well, y equals x squared doesn't go below 0 here, so they're not part of the range. It's only the y values that this black line crosses. So the range here will be all the positive real numbers, we call them, and 0. And if we looked at y equals -x squared, well, it would be all the negative real numbers and also 0. Okay, so we've got range. Now we want to look at the axis of symmetry. So the axis of symmetry is the line about which the graph is symmetrical. Now you can see here that the parabola, it's the same on the right hand side as it is on the left hand side. So we say it's symmetric. Now we say it's symmetric about the y-axis here. Now the third term we need to know the definition of is the turning point. The turning point is the point where the gradient is 0. Now you don't need to worry about this too much. We're going to look at this later on. But you can see here that if you look up here at the graph, it's going down, it's going down, it's going down. And then it stops here and then it starts increasing. So it's going down, 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 stops, and then goes up, up, up. And just like here, it goes up, 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 stops, and then back down, 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 down. So the turning point would be 0, 0 for y is equal to x squared. Okay, so that's just a brief intro to parabolas. Now, all quadratic equations are of the form y is equal to x squared plus bx plus c. So this is the general form. But what we're going to see is that all of them can be written in the form y is equal to a bracket x minus h squared plus k. So this is the turning point form. And we like this one a lot more because we can graph it a whole lot easier. So all of them can be written like this. And we'll look in chapter 3E, I think it is, we're doing 3D now, yep, 3E, on how we can get them from one form to the other. So don't worry about that now. Okay, so let's look at question, first we'll look at y is equal to ax squared, where a is just some number. What that means is it's just like what we graphed up before for y equals x squared, but it's been dilated by a units. When we mean dilated, when we say dilated, we mean expanded or contracted. So if you think about your pupils dilating, they expand. So they're dilating, they're getting bigger. But we also in maths say dilating is in getting smaller as well. So it just means keeping the same shape, but changing how big it is. Okay, and let's also look at what happens when we have y is x squared plus k. Well, that's just the same as y is equal to x squared, but it's been moved up by k units. So it's the same parabola as we had before, but it's just been moved up or down by k units. Let's look at an example of this. Let's look at 1f. So on 1f we have y is equal to 3x squared minus 9. Now what we're going to do is we want to find 3 bits of information and then we want to graph it. So the first bit we want to find is the coordinates of the turning point. Okay, well, before the turning point was 0, 0. Now all that's happened here is we've dilated that by a factor of 3. We've also moved it down 9 units. So if it was a positive 9, we'd go up for 9 units, but since it's negative 9, we go down 9 units. So it hasn't moved any units left or right. So we know the coordinates of the turning point would just be, well, it used to be 0, 0, but now it's 9 units down, so it's actually 0 minus 9 now. Now the second bit of information we need to find is the axis of symmetry. Well, the axis of symmetry before was the y-axis. So if we scroll back up, it was just the y-axis. Now what's happened with this parabola here is it's just moved down 9 units. It hasn't moved left or right, so it's still going to be symmetric or symmetrical about this y-axis. So the axis of symmetry is still the y-axis. And if you want to be exact, it's when x is equal to 0, because the y-axis is just where x is equal to 0. Now the third thing we need to find is the x-intercepts, if there is any. Now to find the x-intercepts, we did this earlier with linear equations. We want to find where it crosses the x-axis. So what we do is we let y is equal to 0. Because up here, to find the x-intercepts, we want to find where it crosses the x-axis, we just let y is equal to 0. And you'd get up here, you get, well, it crosses the x-axis when when x squared is equal to 0. Therefore, it's when x is 0. So let's look down here. Alright, so let y equal to 0. That means we've got 0 is equal to 3x squared minus 9, because we've just substituted y equals 0 into up here. And then we'll take our 9 here to the left-hand side. So we'll get 9 is equal to 3x squared. And what we'll do next is we'll divide both sides by 3. So we'll get 3 is equal to x squared. And then we'll take the square root on both sides. So we'll get x is equal to plus or minus, because remember you've got to do plus or minus, the square root of 3. Okay. Now we have, oops, what did I do there? Now we have enough information to graph the parabola. So I'll draw up our Cartesian plane. Oops, S, don't know where S came from. Alright, so we know the turning point is at 0 minus 9. Just here. We know the axis of symmetry, well, x is equal to 0. And a little trick as well, the axis of symmetry is just going to be the x coordinate of the turning point. So x is equal to 0, you can make that connection there. Okay, so it's going to be symmetric about the y-axis. And we also know that it's going to intercept at the square root of 3. Now, what's the value of the square root of 3? You can chuck it into your calculator, but it's somewhere between 1 and 2. And minus 1 and minus 2. So we know it's going to pass through here somewhere. There we go. We've got our parabola. Chuck it into your CAS as well, and you'll be able to see how correct you are. Alrighty. Now let's have a go. Let's move on to, so we've done moving up and down. We've also done dilating. Let's look at when we have the equation y is equal to x minus h squared. What that is it's the same as our regular parabola, except it's moved h units, but it's moved h units to the right. All right, let's have a look at, so it doesn't change the shape of the curve, it just changes its position. So let's have a look at 2a. Now I've got y is equal to x minus 2 squared. So it's the same as y equals x squared, but it's moved to the right by 2 units. There we are. And it's probably pretty good to find the y-intercept here as well. So to find the y-intercept, what we do, we let x is equal to 0. So we get y is equal to 0 minus 2 squared, which is equal to minus 2 squared, which is equal to 4. So it's going to cross the y-intercept, the y-axis up here at 4. Great. Okay, so there are 3 transformations really. So we've got when it's moving left and right. Now remember that it doesn't change the shape of the parabola, it just moves it left and right. Then we've got it moving up and down. Again, that doesn't change the shape, it just moves it up and down. And then we've got it being dilated. So that does change the shape. So it's not moving left or right, it's just changing the shape, making it bigger or smaller. Okay. What we'll do now is we're going to do a combination of all 3 of those different transformations. So let's graph 3G. So we've got y is equal to 2x plus 2 squared minus 18. All right, so let's look at our 3 transformations. So we've got dilation, up or down, and right or left. So we can see here that it's being dilated by 2. Now, if it's a dilation greater than 1, it means it's an expansion. Now, is it going up or down? Let's change the thickness. Well, it's negative 18, so it's going down by 18. And then it's got plus 2 here. It might be counterintuitive, but we're actually going left by 2. Because remember, when it's x minus 2, it goes to the right 2. So if it's x plus 2, it goes to the left by 2. Okay. So now we can graph this. I'll start to graph it. So it's moved down by 18 and to the left 2. So let's look at the axis of symmetry first. Now, when you move up or down, it doesn't change the axis of symmetry, but when you move left or right, it does. We can see up here when we move to the right by 2, it changed its axis of symmetry by 2. So we know since it's moved left by 2, the axis of symmetry will be left 2 as well. And what's left of 2? Sorry, what's left by 2 of the y-axis? Well, it's here, minus 2. So that'll be our axis of symmetry. Okay, now our turning point. Well, we know our turning point will occur on this axis of symmetry here. And we also know that the graphs move down by 18. So our turning point here is going to be minus 2, where x is equal to minus 2, and y is equal to minus 18. So this will be our turning point here. Now, what else do we need to do? Let's get some intercepts. Let's look at the y-intercept first. So remember, the y-intercept is where x is equal to 0. So actually, I'll do it up here. So it's when x is equal to 0. So you go y is equal to 2, and you plug in 0. So that'll give you 2 squared minus 18. So 2 squared is 4. And that'll give you minus 10. So it's going to intercept up here at minus 10. Now we'll also find the x-intercepts now. They're going to be a bit harder. So we'll let y is equal to 0. So we've got 0 is equal to 2x plus 2 squared minus 18. Now we'll take the 18 to the left-hand side. So we get 18 is equal to 2x plus 2 squared. Let's divide by 2. So we'll get 9 is equal to x plus 2 squared. Now what we'll do is we'll take the square root on both sides. So then we'll get plus or minus 3 is equal to x plus 2, because those square roots cancel out. And then now what we'll do is we'll just take 2 on both sides. So we'll get minus 2 plus or minus 3 is equal to x. Okay, so this it's not super neat, but all the 2 cases, so we'll do minus 2 plus 3 first, and minus 2, minus 2 minus 3. So that's minus 2 plus 3 is 1, and minus 2 minus 3 is minus 5. So there are x-intercepts. So 1 and minus 5. So we know it's going to pass through these 4 points. Super neat. Thanks for appreciating that, guys. And so here we go. Here's our parabola. So again, what did we need? We looked at our axis of symmetry. Now, axis of symmetry was determined by moving left or right. Our turning point. So we need to know how left and right it goes and how up and down it goes. And then our y and x intercepts. Oops, what's happened here? We've got to do some calculations for them. Righto. Now you notice here they're all smiley faces that we've done, and that's because in front of this all the numbers have been positive. So you can see here it's positive. But it could have easily been negative, as we showed up here at the very beginning, and it could have been a frowning face. So don't be too worried if it is a negative in front. It just means you're going to be graphing a frowning face. Okay, so let's actually go back up to the top again. So can we find, given a quadratic equation, can we find its x-intercepts? Yep, we can. Can we find its y-intercepts? Yep. Can we find its turning point? Yes, we can, because the turning point just looks at if it shifts left and right and up and down. And then can we graph it? Yes. So you need to be able to do all this to do the graphing it. All right. That was quite a lot of information, guys, so do pause as you go along. Bit late to say that now, I guess. And I'll put the homework questions up in our Google Drive doc as well, so don't worry about that. Awesome. See you later, team. Like and subscribe, etc., etc., etc.